right, it's called the difference of two squares. Okay, now difference, all right, means subtract, right? The difference of two numbers. All right, so this right here indicates that, hey, I better have a minus sign in my problem. All right, it also says it's the difference of two squares. So then that means I'm only going to have two terms. That right there tells me I'm only going to have two terms. Okay, and then the fact that they've used the word squares means that the numbers need to be perfect squares. Okay, so we're going to review this idea of perfect squares, okay, from middle school. Okay, you did square roots. Okay, you did square roots in middle school, and most of the time you probably did the perfect square roots. So in other words, in middle school you learned that the square root of 9 is how much? 3. Okay, because 3 times 3 is 9. All right, and then the square root of 16 is 4. Okay, now I'm doing a pattern here. Square root of 25 is 5. Okay, so can you guess what square root I would do next? 36. Because the square root of 36 is 6. So what would the next one be? 49, because that one is 7. And then next one would be 64. The next one would be 81. Can we do the next one? 100 is the next one. Now, who can do the next one? 121. Because that's 11. We ought to at least be able to go one more. Close. 144. Square root of 144. All right, and that's 12. All right, these numbers are perfect squares. So the difference of two squares, we're going to look for these numbers or other perfect squares, because obviously couldn't I keep going with this list? I could keep going and keep going and keep going with that list. But for the most part, the numbers are probably going to be small. All right, so as long as these perfect squares are in our problem, then, and we have two terms, and we have a minus sign in between there, then I know I have the difference of two squares. So those are the things you're going to look for. You're going to look for two terms. You're going to look to see if they're perfect squares, and then you're going to see if there's a minus sign. Okay? Now, we also can take square roots of variables. So perfect squares with variables in them are going to be, say, the square root of x squared. That one's going to be x. The square root of x to the fourth is going to be an x to the second. The square root of x to the sixth is going to be x to the third. The square root of x to the, what's my next number? 8 will be an x to the fourth. You can think of it as taking half of the exponent as a shortcut. You can also thinking of square root. If they didn't tell you this in middle school, there is a little imaginary 2 there that we never write because it's a square root. All right, a little bit later when you go to Algebra 2, you're going to learn about cube roots. You might have even done cube roots in middle school. Or fourth roots or fifth roots. So a little bit later, you will be doing like the cube root of 8, all right, in higher math classes. You'll do the fourth root of, say, 16. All right, so same concept. We're just not there yet. So square roots, since this is a third root and this is a fourth root, square roots, we never put the 2 in there because it's imaginary. We just know that a square root is there, but technically there's a 2 there. Now, isn't 2 divided by 2 1? And isn't 4 divided by the imaginary 2 2? 6 divided by the imaginary 2 is 3. Okay, so you can think of it as you're taking half. All right, you can also do that little trick of 8 divided by the imaginary 2 would give you the 4. All right, but this is because why? X to the fourth times x to the fourth. When we multiply like bases, what are we supposed to do with those exponents? We add them, right? And that's really what the definition of a square root is. You take the whatever number it is, 3, multiply it by itself. 3 times 3 gives you the 9. So then in this case, if I say that my square root of x to the 8th is x to the 4th, well, it's because x to the 4th times x to the 4th, when I multiply them, I get the x to the 8th. All right, so those are the answers. And then could I keep going? Yes. So as long as I have an even number on my exponent, they are perfect squares. Okay, so I can do it with variables because we know all these problems are going to have variables, and we know that they're going to have some numbers. This one is going to be the most common one. Okay, all right, so that's your preface. That's your early work here on what this is and what this means. Okay, now what these problems are going to look like. They're going to have two terms. They are going to have a minus sign, and they're going to have perfect square roots. So if I had an x squared minus, maybe say a 49. Okay, do I have two terms? Yes. Do I have a minus sign? Is 49 a perfect square root? Is x squared a perfect square root? Yes. So now, I'm going to, on this first one, I'm going to write this down, but then you're not going to write this down afterwards. If I take the square root of x squared, what do I get? X. If I take the square root of 49, what do I get? 7. So these two numbers I'm going to use, and I am going to write them with a plus sign and a minus sign. So I'm going to write an x plus a 7, and then I'm going to turn around and write x minus 7. All right, I'm going to memorize it. I know every time that the difference of two squares is going to factor like this. All right, whatever this term is, when I take the square root of it, it was x. That goes in the front. When I take square root of this number, which was 7, it goes second. And I will always put one with a plus and one with a minus. We know that is called the difference of two squares. So that right there is the answer. All right, now technically, if I wanted to FOIL that out or multiply it out, I could check it. I could check to see if it works. All right, on this first one, let's go ahead and do a check just to see. We won't do a check on all of them, but we'll check on this one. All right, so if I am going to do a check, I should be able to take x plus 7, x minus 7, and I should be able to do our repeated distributive property, multiply it back out, and get what I started with. All right, so we would do x times x, which is x squared. We would do x times the 7 with the negative, which would give me a negative 7x. Okay, then we would take this 7 times x, well, positive 7 times x. We would go to our second row, line it up, because we know we got like terms. All right, and then we would do the 7 times the negative 7, which will be a minus 49. 7 times 7. I would add going down. That'd give me an x squared. What's a negative 7x plus 7x? 0. So that falls out. So then the only part that's left is the minus 49. And yes, it checks when I multiply it back out. Now, like I said, you're probably not going to multiply it out every time, okay? But you can multiply every answer out and check to see if you are right. Okay, now let's do one that's like an x squared minus 81. X squared minus 81. Do I have two terms? Yes. Do I have a minus sign? Yes. Is the first one a perfect square root? Is the second one a perfect square root? Yeah. So then, if you need to see it and visualize it, the square root of x squared is what? That's an x. What's the square root of the 81? That's 9. So these are the two numbers that I'm going to use. I'm going to write them with a plus sign. I'm going to write them with a minus sign. So I'm going to write x plus 9. I'm going to write x minus 9. And then I know I'm done. So those are the straightforward, and those are the easy ones. All right. Let's do one that has a coefficient in front. Let's do a 4x squared minus a 30. I didn't want to do 36. Oh, no, let's go ahead and just leave it at 36. That's a good one. Do I have two terms? Yes. Do I have a minus sign? Is the first one a perfect square root? Yeah, because I can take square root of 4, and I can take square root of x squared. So, yeah, can I take square root of 36? Yes. 6 times 6 is 36. Now, some other technique that we've already learned. Do I have a greatest common factor? What number goes into 4 and 36? 4. All right, so we can't ever forget about those greatest common factors. So before I get all worried about doing the difference of two squares, I need to remember that greatest common factor. I can take out a 4 first and then do an x squared minus, what's 36 divided by 4? 9. So I got to remember to do that first. And then what happens when we have that greatest common factor out in front? It just kind of comes down and it's there in our final answer. All right, now I look on the inside. Do I still have two terms? Yes. I still have a minus sign. The x squared still a perfect square. Is the 9 a perfect square root? Yeah. So then this is, can we do it without writing this down? It's going to be a 4, and then it's going to be a what? X plus 3, and then x minus 3. So that one was taking out a greatest common factor first, and then doing the difference. And they're gonna expect you to be able to do that. That would be obviously a more challenging one. Okay. All right. Now, are they going to try to trick you sometimes? Yes. Because sometimes they might give you something like an x to the 4th, and then plus maybe say a 100. Do I have two terms? Yeah. Is x to the 4th a perfect square root? Yeah, because it's even. So yes, it is. Is 100 a perfect square root? Yes. But do I have a minus sign? No. All right, so because I don't have a minus sign, because that is a plus, all right, I cannot factor that. All right, that is not the difference of two squares because it's a sum. All right, so on this one you would write cannot factor because it is not the difference of two squares because that plus sign. The plus sign is what's making it not work. It's not the difference of two squares. All right, so do we think we can do this? All right, in your notes, let's label practice. And then we'll just do 3 real quick. Try those 3. I'll give you a minute to try them. Okay, you've got your perfect squares written down there because we wrote those down early in the notes. So if you need to use them, you can. Squared and then putting the answer down, and then the square root of 100, that's perfectly fine. Okay, so Aaliyah, when I take square root of x squared, what do I get? X. All right, and then Olivia, when I take square root of 100, I get 10. All right, so if you're writing that, that's fine. All right, that lets you visualize that you've got to use an x and a 10. Okay, and then Savannah, so what do you write as final answer then? Yep, x plus 10, x minus 10. All right, now, if you do not have to write this, if you can just do that in your head, then that's fine. You don't have to write that. But those of you that are wanting to write it, that's perfectly fine. Okay, Hannah, on this one, what's the square root of x squared? X. Matthias, what's the square root of 144? 12. Okay, Cheyenne, can you tell me then what I'm supposed to write? I'm supposed to write... Yep, x plus 12 and then an x minus 12. All right, now on this one, all right, I made it more than just an x squared. Can we take the square root of an x to the 4th? Yeah, so that's going to be an x to the 2nd. So we'll have to do that one. And then square root of 49 is 7. So on these, what am I going to write? Zoe, what am I going to write on this one? I'm going to take these two things right here. I'm going to take the x squared and I'm going to take the 7. So, I didn't hear you. X squared plus 7. You are talking very, very soft. And then what's the next one going to be? Yep, x squared minus 7. All right, now technically, should I check to see if these would work? Because isn't this 2 terms? That's 2 terms. I got a minus sign. Is x squared a perfect square? Yes. Is 7 a perfect square root? Can I take the square root of 7? Was that on the list that we wrote at the beginning of class? No. All right, so then that means this is not the difference of 2 squares, so that is the final answer. Then you are done with that. All right, most of the ones that you're going to counter, though, are just going to have the x squareds. All right, and then they might have a greatest common factor in the front. Okay, they might have a greatest common factor in the front. All right, let's do 4 more. So I'm going to draw a little line. I'll put these in blue. I'm going to put coefficients in front of each one of these. Well, at least in front of 2 of them. Okay, we've got several people done. All right, can we take the square root of 4x squared? Yeah, because we can take the square root of the 4. What's the square root of 4? 2. What's the square root of the x squared? X. Can we take square root of 49? Yes, that is 7. So then I'm going to take the 2x and the 7, and then that's what I'm going to use. I'm going to write 2x plus 7, and then I'm going to write 2x minus 7. Okay, on this one, it might be helpful on this to do the square roots. Can you do the square root of x squared? Square root of 25x squared. Square root of 25 is 5. Square root of x squared is x. So that first one's going to be 5x. Can I take square root of 64? That's going to be 8. So then that means I'm going to use these 2 things, the 5x from here and the 8 from here, and I'm going to write 5x plus 8, and then I'm going to write 5x minus 8. You always write it with a plus, and then you always write it with a minus. Okay, now this one's back to one of the normal ones because they don't have a number in front. Are they both perfect square roots? Yes. Minus sign in between? Yes. So it's going to be an x plus 5 and an x minus 5. All right. How many people got all 6 right? Anybody get all 6 right? Anybody get 5 out of 6 right?